Hey, 7th grade. Enjoying day 2 of me not being there in these videos? I hope so. Today we're talking about LCM and LCD. Again, I was told you guys know what these mean. Let's start with LCM. LCM stands for least common multiple. And the least common multiple is the least non-zero multiple that is common to all the numbers. Whether I'm comparing 2 numbers or 10. This definition should be pretty easy to compile. It involves the words least, common, and multiple. Aha. So again, with least common multiples, we have 2 methods to help us solve. Method 1 is listing the multiples. So this is probably the strategy you're most used to seeing. If I want to find the LCM of 4 and 6, well, I start with 4 and I list out the multiples. So 4, 8, 12, 16, so on and so forth. Then I take 6 and I list out the multiples. 6, 12. I'm going to go ahead and stop because I have found the least number that is in common. If I extended this and went to 18, 24, and I extended my top list beyond 16 to 24, 24 is not going to be my least common multiple because I had a least common multiple before it. So here my LCM is 12. Method 2 you will have seen before, not for LCM necessarily, but if you think back to GCF, it was method 1 in GCF, and that is prime factorization. So prime factorization means I do my factor trees. So 4 is 2 and 2, 6 is 3 and 2, and if I list those out like I did last time, 4 times is 2 times 2, 6 is 3 times 2. I don't look at the column where they're in common. I don't look at that GCF column that I would have looked at before. I look at the numbers they don't have in common. So 2 and 3, that's 6. If I was to multiply 6 by at least one of these 2's from this pair, so these 2's I'm going to say make a pair, and out of that pair I pick one. It doesn't matter which one because they're both 2's. So I have a 2. 6 times 2 is 12. That gives me that LCM. This one may take a little longer to get used to than this. It is a lot less work when you get good at it to do this rather than to list these out, especially when we have numbers that are bigger than 4 and 6. If I need to list the common multiples of 96 and 108, I'm going to be sitting for a very long time doing this list, whereas if I do a prime factorization tree, I may have it a lot quicker. So you can use LCM to find more algebraic terms, to extend a sequence, So if I had, and I may have some algebraic terms with letters, so if I had c squared and b squared c cubed, this would be one where my prime factorization is going to be more handy than listing the multiples. C squared, that's c times c. B squared, c cubed, we can split it into the b squared and the c cubed if you'd like. B squared is b times b. C cubed is c times c times c. And this may be an easier way to see it. Anything that has a pair, I'm going to circle. So this c and this c is a pair. This c and this c is a pair. Again, for each pair, I pick one. So c times c. Then all the stuff that doesn't have a pair, I multiply together. B times b times c. These b's aren't considered to have a pair because there's no b's over here. My pairs have to be across the two numbers. So this pair, they cross the two numbers. So again, my b's don't have a pair. When I multiply all these together, b times b is b squared, c times c times c is c cubed. This is my LCM. Yes, it is the same as this. That's okay. If I wanted this c squared to look like this is what I would need to add in. So this is my least common multiple. Those are pretty much the two kinds of least common multiples you'll see in the homework. So we're going to move right along to least LCD, least common divisor, or least common denominator you may be more familiar with. So, LCD, least common denominator. And that is the least common denominator of two or more fractions and when we say we're looking for the LCD, it means we're really looking for the LCM of the denominators. So if I have the fractions 1/12, 3/16, and 5/18, in fact, let's make the 3/16 negative. It really doesn't matter. That negative can affect either the numerator or denominator, but not both. So I want to find the common denominator, or the least common denominator of 12, 16, and 18. I can do the list method. I can do the prime factorization method we saw up top. It does not matter. Because you've seen the list method so often and not as much on the prime factorization, I'm going to solve by prime factorization. So I have 12 is 4 and 3. 4 breaks down to 2 and 2. 16 is 4 and 4. Each of those 4s break down to 2 and 2. 18 breaks to 9 and 2. 9 breaks to 3 and 3. This is where it gets tricky. I'm going to circle my factor pairs. Now, because I have 3 numbers, I'm not necessarily working for pairs, I'm looking for triples. So this 2, and this 2 all belong together. Do we see any more triples? We shouldn't. That's as far as I can go. So I'm going to take 1 from that triple, that single 2, and then I have all these other numbers I have to add into my equation. So from 12 we have another 2 times 3. From 16 we have 3 more 2's. That should be 3. And from 18 we have these 2 3's. When I multiply all that together, I get my LCM, or in this case an LCD. That LCD is 144. If you want to spend time multiplying them out, go ahead, but I'll go ahead and tell you it's 144. If I have B's in the equation, or C's or whatever, it works the same way. I'll do an example of that though, just to make sure we have this. If my fractions are 6C over 5B, 2C over 15B, and 7C over 25B. I don't even care about these C's up top. I'm not looking for a greatest common or least common numerator. I'm only looking at the denominators. So we have 5B, 15B, and 25B. Again, I'm going to do the prime factorization method. 5 is prime, B is prime. On 15, that breaks down, 15 breaks down into 5 and 3, and also B. 5 and 3 are both prime, B is prime. 25 breaks down into 5 and 5, and B. So I'm going to circle my triples. Again, I have triples because I'm comparing 3 denominators. So I see that there's a 5 in each, so I'll circle those. I see that there's a B in each. I will circle that. Those are my 2 triples. I just need 1 from each triple, so 1 of the 5's and 1 of the B's. Then I factor in all the numbers I didn't circle. So I've circled both of these. This isn't circled, this isn't circled. So I have 5B times 3 times 5. This will be 75B. That is my least common denominator. So if I wanted to make these all have equivalent denominators, this first one, 6C over 5B, to get it to have a denominator of 75B, what do I need to multiply top and bottom by? This goes back to GCF, finding the greatest common factor between 5 and 75. It's of course 5. I need to multiply by the rest. So what gets from 5 to 75? I multiply by 15 on top and bottom. 5B times 15 will give me 75B. 6C times 15 will give me, we can work it out over here, $90C. So I have 90C over 75B, and I repeat that for 2C over 15B and 7C over 25B. Of course, each time I won't need to multiply by 15. When I go to do 2C over 15B, and I want to get to a common denominator of 75B, I'll need to multiply top and bottom by 5. So that'll give me 10C over 75B. When I come over here to do 7C over 25B to get to a common denominator of 75B, I multiply top and bottom by 3. 3 times 25B, 75B, 3 times 7c, 21c. This should look like all the problems you might see in your homework. I tried to select ones that had a few letters but not too many, so that it didn't become overly confusing getting hung up on the letters. Your quiz tomorrow will have GCF problems, LCM, and LCD. It will probably have, since LCD and LCM are so related, it will probably have one of each of those and 3 GCF problems, as well as maybe a bonus. We'll see. Good luck. I hope you don't need it, but if you need it, I hope you find it.